Alrighty, so let's finish up example 2, part C and D. So in part C, we're given x cubed minus 12x greater than or equal to x squared. Right, so to determine which terms I'm going to move over, I'm going to first find my leading coefficient, or my leading term, and that is my x cubed. And I notice that the leading coefficient is positive, so therefore this tells me I'm going to move over my x squared. Okay. When I do that, I get x cubed, and then when I add it to both sides, I'm going to also make this in descending order. So this is going to be plus x squared minus 12x, and then this is going to be greater than or equal to 0. If I denote this as my f of x, okay, this tells me that I want my f of x, I want to find when f of x is greater than or equal to 0. All right. So now let's factor, okay. So I look at this, and I notice they all have x in common. So I'm going to factor out that x. And when I do that, I'm left with x squared plus x minus 12 is greater than or equal to 0. Okay, looking at this, the quadratic inside the parentheses, I want to find two numbers that multiply to be negative 4 and add to be 1, or sorry, multiply to be negative 12 and add to be 1. In that case, it's going to be positive 4 and negative 3. So this is x plus 4, x minus 3. Okay. Remember, the only reason why I was able to put the 4 and negative 3 right away was because my leading term, or in this parentheses, was 1. Right? The coefficient was 1. Okay. So now that this is in factored form, I'm going to find the boundaries. Okay. Finding boundary points. Right. And so to do that, so remember, finding boundary points is also another way. It's one way to think about it is just finding your x-intercepts. Right. So I get x is equal to 0. By the zero product property, then this is negative 4, 3. Okay. Before I plot these, I'm going to put this in increasing order. So when we plot them on the graph, we won't make mistakes. Hopefully. 1 second, I want this to be black. Okay, so here's our number line, and I'm going to plot. So this is negative 4, 0, and 3. Okay. And then to determine if they have an open or closed circle, I'm going to look at this inequality right here. Since it says, since this is greater than or equal to, it has this equal to sign, so I know these are going to be closed circles. Right? And then before I break these up, so, or I guess we can break them up. Okay, but what are my intervals? So I'm going to have 4 intervals. Okay, so what are all my potential ones? I have negative infinity to negative 4. I'm going to put a bracket because of the closed circle. So be negative 4 to 0, 0 to 3, 3 to infinity. Right, and remember, when you have infinity, no matter negative or positive, it's always attached with the parentheses, okay? Because it can never be infinity, all right? So now let's test our intervals. Okay. Oh, I guess before we test it, we have to pick numbers, right? So a number between negative infinity and negative 4, we can pick negative 500. Okay, I'm going to pick negative 3. Okay, unfortunately, we can't pick 0 in any of these intervals because 0 is a boundary point. So I'm going to pick 1 here, and then over here I will pick 500. Okay, so testing intervals. Okay, looking at interval 1, okay, I have f of negative 500. Okay, this is equal to negative 500 times negative 500 plus 4, negative 500 minus 3. Okay, so negative 500, that's negative, and then this is negative, and this is negative. When you multiply 3 negative numbers, you will end up with a negative number. So what does this tell me about f of x? For the first interval, f of x is less than 0. Okay, So writing it up here, this is going to be negative. Right. And then like if I'm working, determining my intervals as I work, I notice, so since my f of x is less than 0, but I want f of x greater than or equal to 0, this tells me I do not want this interval. Okay, so we can put an x right here. For the second interval, we have f of negative 3. Okay, so it's negative 3 plus 4, negative 3 minus 3. Okay, so this is negative, this is positive, this is negative. Okay, and I'll end up with a positive number. So f of x is greater than 0. So looking up, remember we want f of x greater than or equal to 0. So this interval will be part of my solution. Looking at the third interval, we have f of 1. So this is 1 times 1 plus 4, 1 minus 3. Okay, so this is positive, positive, and negative. So this gives me a negative. What does this tell me? This tells me f of x is less than 0. So again, not a part of our solution. Right, now let's test the fourth interval. The fourth interval, we want to find f of 500. Okay, this is going to be 500. 500 plus 4, 500 minus 3. This is positive, positive, and positive. So this gives me a positive number. So then f of x is greater than 0. Okay, so again, so this is also a solution. Okay, so if I want to write this in interval notation, okay, then this is going to be negative 4 to 0, union 3 to infinity. Okay, and these are the values of x when my y's are positive. Okay, or equal to 0, when my y's are greater than or equal to 0. Right? So, give me 1 second. Alrighty. So, back to the problem. So what does this mean when you look at a graph? Okay, if I plot all the x-intercepts, so this is going to be negative 4, and then our 0, and then our, say this is 3. Okay, looking at the graph as a whole, what this means is in the first interval right here, my y values are negative. Okay, the second interval from negative 4 to 0, okay, it's going to be positive, right? And then when it's negative, it's going to be negative from 0 to 3, and then it's positive up here. Okay, again, this is not the true graph, but I'm just saying that this is generally what it means. That means, like if you split this, okay, this is when it's negative, and this is when it's positive for my y's. And as you can see, from negative infinity to negative 4, it's negative, and then from 0 to 3, it's negative. And also, as we determined, negative 4 to 0 is positive, 3 to infinity is positive. All right? So now, let's talk about example D, okay, which is x plus 6, x squared minus 16, 1 minus x is less than or equal to 0. Okay. Luckily, when this graph, so it's mostly factored, but if I want to write it as a product of linear factors, I have to do one more thing. But this is already telling me, so remember this is my f of x. Okay, so immediately I know our goal is to find when f of x is less than or equal to 0. Okay, we want to find when our y's are negative. Okay. So before I find the boundary points, I notice x squared minus 16, that is a difference of squares. So let me write that as x plus 4, x minus 4, and this is 1 minus x. Okay, so finding boundary points. Okay, then I have x plus 6, plus 4, x minus 4, 1 minus x is equal to 0. Okay, so then we have x is equal to negative 6, negative 4, 4, and 1. Be really careful with this one. Remember, it was 1 minus x equals 0. So then this is 1 is equal to x. You can say x is equal to 1. If you wanted to subtract it, you could have gone negative x equals negative 1. Divide both sides by negative 1, so you get x is equal to 1. Right? Either way, you'll get the answer. Okay. Luckily, I look at the... Oh, never mind. I was going to say it's in increasing order, but it's not because I need to switch my 1 and 4. So, drawing a number line, I am given negative 6, negative 4, 1, and 4. To determine if I'm going to do open or close circles, I'm just going to look at the problem itself, and I notice that it's less than or equal to. So, since it has that or equal to sign, these are all included. Okay. So writing the intervals beforehand, okay, so notice since we have 4 boundary points, we're going to have 5 intervals. Okay, it's always that plus 1. It's the same as when you look at polynomials, how many terms it has, you look at the degree, and then add 1. Okay, so this is going to be negative infinity to negative 6. Okay, so again, the reason why I'm doing brackets is just so we don't have to remember it when we write the answer. Okay, and remember, so the only reason why I have brackets is because this is included. If it was not included, then these would all be parentheses. Right? So this is interval 1, 2. So if I just draw these, just split them up. Okay, intervals 1, 2, 3, 4, and 5. All right, and now let's pick numbers to test. So, I don't know, we can test negative 25, negative 5, 0, 3, and 50. Okay. Or it does not matter what number you pick, as long as that number is within your interval. If it is outside the interval, then you have picked a wrong number. All right. So, let's see, testing intervals. When I do that, so testing the first interval, I'm given f of negative 25. Okay, so this is going to be x minus, negative 25 plus 6, negative 25 plus 4, negative 25 minus 4, 1 minus negative 25. Okay, so this is going to be negative, 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 and this one is going to be positive. Okay, 1 minus a negative becomes 1 plus. All right, I look at this and I'll get a negative. Okay, so it just tells me about my first interval. This tells me that this is going to be less than 0. My second interval, I have f of negative 5. All right, so this is negative 5 plus 6, negative 5 plus 4, negative 5 minus 4, 1 minus a negative 5. Okay, so this is positive, negative, negative, positive. Okay, so this gives me positive. So this tells me f of x is greater than 0. So I get the third interval, so I have f of 0. This is going to be 0 plus 6, 0 plus 4, 0 minus 4, 1 minus 0. So this is going to be positive, positive, negative, positive. So I'm left with a negative. So this tells me that my y's, my f of x's, are less than 0. Testing my fourth interval. Okay, f of 3. This is equal to 3 plus 6, oops, 3 plus 4, 3 minus 4, 1 minus 4. Okay, so this is going to be positive, positive, negative, and a negative. Okay, so then this, okay, let me rewrite that. That looks awful. Okay, so I'm left with positive. So this tells me that f of x is greater than 0. Finally, let's test f of 50. So I have 50 plus 6, 50 plus 4, 50 minus 4, 50, oops, 1 minus 50. So I'm left with positive, 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 negative. Okay, this is negative, so then f of x is less than 0. Okay, to be honest, I thought I picked an example that did not alternate. Obviously, I did not. So let's finish this example, and then I will show you what to do when you get, when intervals you see are the, like if this is positive and this is positive, right? So remember what was our goal? Our goal is to find when f of x is less than or equal to 0. So this was negative, and then, okay, since they were all alternating when we solved it. Okay, so just looking at this one, you can also look at these intervals as well, but I'm just going to look at this graph. Okay, since f of x is less than or equal to 0, so I don't want it when it's positive, right? So in my interval notation, this is going to be negative infinity to negative 6, union negative 4 to 1, union 4 to, oops, infinity. Oops, crap. Right, and this is our interval notation. If you were to graph it, okay, it would have just been not to scale. So this would have been here, and this would have been here, and then right here. Okay, or you could just, to see it easier, like that. Okay, this is what my graph would look like. Very rough. Okay, so sorry. Let me steal a graph, because yeah, that is just awful looking. So let's try again. Okay, so this is negative 6, negative 4, 1, 4 to infinity. So it's all of this, and all of this. Right, and that's what your graph would look like. Right, so since I have failed to show an example of when they don't alternate, okay, we're not going to do a specific like polynomial, okay, but we'll just talk about, I'll make a little table. Okay, so, oops. For example, I don't know, say that I have negative 6, negative 2, 3, and 7. Okay, say that these were all my zeros. Okay, so interval 1, 2, 3, 4, and 5. Right. And let's just say, so since the last two were not are included, I'm just going to pretend that they're not included. Okay, when f of x is equal to 0. So my intervals would be negative infinity to negative 6, negative 6 to negative 2, negative 2 to 3, 3 to 7, and then 7 to infinity. Okay? So let's just pretend if this one, say this one is negative, positive, positive, negative, negative. Okay? Maybe let's add another one. I'll call this 10. Oops. Let's say this is positive. Oh wait, this is interval 6, and here's that. So then I have to change this. This goes from 7 to 10, and then this would be 10 to infinity. Okay. So I'm just going to show you both of them. So when f of x is less than 0, okay, my interval would be negative infinity to negative 6, union, and as you can see, because these are both, okay, I'll show you, okay, sorry, I'm going to show you all 4 of them, or maybe, yeah, I'll show you all 4. So if this one was strictly less than, this is going to be 3 to 7, union 7 to 10. The reason why is because 7, since it is a 0, but we want it strictly less than 0, I cannot include 7 in my interval for this case, right? And that's when it's less than. Okay, so what happens if we ask when f of x is less than or equal to? So this is going to be negative infinity to negative 6 with brackets. But now, okay, so since these are both, just looking at them separately, I would have 3 to 7 if I just did it this way. Okay. However, what do these brackets mean? These brackets mean that it's included. So this whole interval will just become one interval because we will allow when f of x is equal to 0. So my interval would be 3 to 10. All right? So you don't need to include this part because 7 is included. We have to split it up here because 7 is not included. Okay. So what about when f of x is greater than 0? So since it's strictly greater than, we cannot include the 0. So this is negative 6 to negative 2, union negative 2 to 3, union 10 to infinity. Right. But when f of x is greater than or equal to 0, okay, again, we include them, and it's the same concept as above here. So if I have negative 6 to negative 2, union negative 2 to 3, okay, as you can see, okay, since they're both included, okay, so we don't need that, okay, because, yeah. So this is negative 6 to 3, union 10 to infinity. Okay, and that's what it would look like for all 4 different cases. So what would it look like as a graph then? Right? So this is my x and y. Okay, so remember these intervals are your x's. Okay, all the x's that make your y either less than or greater than 0, or if it's equal to. So let me bring this guy down real fast just so I don't have to keep scrolling back and forth. Jeez. Oh wait, I apologize for the mess, but yeah. Okay, so a very rough sketch. Okay, this is not accurate, but this is just what it would mean. So if you have negative 6, negative 2, and then 3, 7, 10. Okay, this just means that my y's will start here, so it's just going to be down. Right, and then we have 2. So what this means, so since it's positive, it's going to be positive here, but we know negative 2 is a 0. However, it's still positive from 2 to 3. So what does that mean? This means that it just touches the x-axis. So then, so it just kind of bounces like a ball, like that. Right, and then we go down. So, since they change, value starts from 3, it changes from positive to negative. That just means it crosses the x-axis. And again, so for this, since they're both negative, 7 and 10, then we know that that it touches at 7. Okay, and then we go to infinity. So this is a very rough sketch of what the graph would look like, okay, given this scenario. All right, so that is it for today, and I will see you all on Friday. Bye.